Good afternoon and a very warm welcome to everyone for the today's webinar on designs with a notch of excellence with additive manufacturing for consumer appliances. This webinar will be presented by Mr. Ganesh Babu, who is our National Manager, Application Engineering, Additive Manufacturing. He sits in our Bangalore office. Uh, 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 to tell you more about Ganesh sir, he's come with a vast experience in 3D printing from the last 2 decades. Uh, as I said, he sits in our Bangalore office. He has been graduated from Indo-Danish Tool Room in the year 1991. His association is with the industry and holds various position and has been associated with manufacturing for 2 decades. He has the distinction of being the first Indian to extensively work on the resin-based additive manufacturing technology. Mm, as an technical head additive manufacturing for Design Tech, he is taking care of technology from Stratasys. He has held various positions such as senior toolroom manager for Videocon and other Indian MNC companies. He has set up tool rooms and additive manufacturing departments for multiple organizations. To tell you about more about this tool, so this is a go-to webinar tool. As of now, everybody will be on a mute. We want to have an one-to-one discussion later at the end of this webinar. We will have an Q&A or an question and answers of discussion for say last 15 minutes. You can type your questions. There is a chat window in your options. You can just type your questions over there. We will take it one by one. If you want to speak directly with Ganesh sir, there is an option to raise your hand. You can just raise your hand. I will unmute you and you can ask directly if there is any query with Ganesh sir. Also for the there are few videos in this presentations. To have the better quality of audio, I request everyone kindly use your headset for better audio quality. Also, post this webinar may by tomorrow I will share the the recording of this webinar to you. In case if you have missed anything, you can definitely get back to us. So over to you, Ganesh sir. Please take it ahead.
Very well. Thank you very much, Pranjal. A very warm welcome to all attendees. So, today I'm going to speak to you all on additive manufacturing for consumer appliances. So, we begin this webinar for any of the consumer appliances designs. We talk about a notch of excellence. So, whatever the creator, the designer's creation is all about, we would like to focus on how Stratasys as additive manufacturing technology. There are various technologies that Stratasys offers today in the additive world. How could one be able to materialize in using additive as a technology for realizing design excellence, the best of designs for any consumer goods product? So, before that, let me take you through with a brief in terms about Design Tech. We are a company with 25 years of existence, and we are leaders among the top three when it comes to VARs for CAD/CAM, CAE, PLM, and software solutions, along with additive manufacturing technologies. We have a very strong engineering services domain, and engineering services would offer solutions to our clients from product design to industrialization. And we have augmented reality and mixed reality experience. Well, today's need of the hour, when we focus on AR and mixed reality experiences, we have highly experienced staff to take you through with. So as I mentioned, over 25 years in existence, we have multiple offices all across the country. So I'm based out of Bangalore and our headquarters is from Pune. So across India as well as overseas, we have offices, and Design Tech offers varied solutions today to meet to customer requirements. So the agenda for today's webinar is going to be additive manufacturing or 3D printing. A brief intro. Stratasys additive manufacturing technologies for consumer appliances. Well, I would like to dwell a little bit more on consumer appliances while we talk about our consumer goods or consumer durables. You can name it as you wish. But today, when we talk about consumer goods or consumer appliances, we could see mass volumes, and we also see quite a lot of product changes that keep happening. There are multiple players across the consumer goods manufacturing industry. So the benefit for all these industries begins from the stage of prototyping. So we're talking about manufacturing. So we have prototyping to tooling and manufacturing as applications on consumer goods. There are a brief overview in terms about customer case studies. And yes, the most important subject of discussion. Soon after this webinar ends, we would like to take your questions. I request you all to park your questions, or you may also voice your questions once I conclude with the presentation. So before getting into the product subject, let me take you very briefly through to who Stratasys are. As you could read, the 3D printing solutions company. Well, Stratasys have been pioneers who have been leading the way for additive manufacturing industries. So when we look at polymer-based 3D printing solutions, Stratasys, well over 3+ decades as leaders in additive manufacturing. There are multiple technologies to offer as solutions today that could fit into varied applications, with verticals expanding, starting from education, going up to medical. When we have to look into automotive, aerospace, consumer goods manufacturing, medical applications is also an interesting area where Stratasys Technologies offers solutions that could address quite a lot of demanding needs. Well, across design, manufacturing, and healthcare, a brief overview in terms about some of our customers. So why Stratasys 3D printing? Yes, if you have to have a question, it means, well, Stratasys has, as I mentioned, 3+ decades of experience to understand what customer needs are. Based on customer needs, there have been innovations in terms of materials, technologies. So today we have platforms starting as office shared systems that could work with multiple industrial based materials. Whole lot to talk about. But in this slide, you can see that we are in India, Stratasys existence for 22+ years. We have a very, very strong customer base of 850+, 1,200+ installations. Nearly 45 to 50% of these installations, we are proud to say that Designtech being the platinum partners of Stratasys, we have the largest install base when it comes to competitive value-added resellers of Stratasys in India. So on the mainstream of verticals, education, automotive, healthcare, consumer products, there you see in consumer products, the focus of this webinar is on the subject of consumer appliances. So we have machines all across the listed names here. And aerospace and defense has also got exclusive large printers, multiple technologies that support their requirements. So well, a brief introduction in terms about additive versus subtractive manufacturing. As you could see the animation, additive is to add layer upon layer materials, and opposite to the subtractive technique. Now Stratasys, this is an introductory video for you all to understand more in terms about what these Stratasys additive manufacturing technologies across different platforms could address vertical needs.
Stratasys is shaping the world around us. From 3D printed rapid prototypes and design freedom to manufacturing innovation and production-ready solutions. We believe that what starts with a spark of an idea can now become reality. We see opportunities all around. The products, solutions, and services being developed within our walls today are changing the way things will be imagined, designed, and made tomorrow. Stratasys 3D printing solutions allows us to tap into the unlimited imagination and potential within each of us, helping designers, engineers, and manufacturers transform their capabilities and accelerate their progress across virtually every industry. Stratasys is shaping young hearts, planes with purpose, helping explore the next frontier, accelerating progress, manufacturing earth-friendly efficient designs, and delivering power and energy to the world. Stratasys empowers the dreamers to dream, inventors to invent, doctors to heal, and industry to grow. We are shaping innovation, creativity, discovery, education, imagination, and the possibilities of tomorrow. Stratasys, the 3D printing solutions company.
So while Stratasys as a 3D printing solutions company, when you have to focus on what the advantages over subtractive manufacturing is, yes, subtractive is good for high volume production, right? And you also have the wide range of materials to work with. And with those two advantages today for any consumer appliance manufacturing, you rely upon mass production. But we also need to take into account some of the disadvantages. So the advantages are good once when you start machining your molds or when you have to machine a part. It takes quite a lot of time. You require work holding fixtures, special tooling, so on and so forth. Now designs have to definitely be manufacturable, only then subtractive could support. Or else you'll have the risk of not being able to have a completed part if your designs are not manufacturable. It is unlike with 3D printing or additive manufacturing. And more importantly, in 3D printing, it is the opposite. You need not have to worry about lightweight parts. You would be able to have lattice structures, filigree structures, internal sparse fills in order to achieve lightweighting in manufacturing, but without compromising on the part's strength or its functionality. So the additive advantages, if you're going to look at unlimited design freedom, first to begin with, design freedom. Designers can design to their heart's content. There's no limitation in terms about design for manufacturing. Manufacture any design, however complex it is. You would be able to integrate multiple components together and try to realize consolidated part designs that can be printed, which is unlike to be achieved in subtractive process. And you also have a flexible supply chain. You need not have to look at tooling when you're going to have limited numbers of batch quantities that needs to be manufactured. Whether it is casting or managing any inventory, it works very well with additive manufacturing. But yes, there are a few disadvantages as well. Today, there is a limitation in terms of the materials. When you look at material limitations, then it becomes a challenge for having the end product realization specific to a product's performance. However, there are rapid tooling and other means that could address the shortcoming of materials. But there is no compromise when it comes to the traditional production manufacturing processes. But let us comprehend to say that today additive and subtractive can go hand in hand. Additive as a process to begin with supports design ideas to quickly be established as a physical part or a physical product that could be tried and tested. Hence, the best designs can roll out for product manufacturing. So, well, coming back to Stratasys Technologies, we talked about multiple technologies. Now, let me take you through with each of these 5 different technologies or additive platforms that Stratasys offers. To the left of your screen, we begin with PolyJet, and to the right extreme, you have Industrial FDM. Well, it's been for the last 2 decades or well over 2 decades from the inception of the FDM technology, the patented technology introduced by Stratasys. FDM and PolyJet had a great combination of complementing each other. Now with the introduction of stereolithography, and in the middle you have the DLP process called as Origin P3 and powder bed fusion technology as SAF, selective absorption fusion. So today Stratasys has got versatility in terms about solution offerings of additive technologies. Today there is no limitation in terms about only using a 3D printer for prototyping applications, but customers have moved beyond. All these technologies could offer you to make prototypes, but what next? When we look at applications, industrial uses of a 3D printed part, can a 3D printed part be used as a final part in a product? Well, to answer all these questions today, the ever expanding material portfolio and the technology innovations from Stratasys has given us multiple additive platforms to pick and choose subjective to the next level of applications after 3D printing a physical output from these platforms. So we'll talk about all that while we are looking at PolyJet or industrial FDM, or when we look at manufacturing tools or production parts or high volume production from SAF and Origin P3, they're all uniquely positioned to support consumer durables manufacturing. Let me begin with FDM. Well, these are robust industrial grade 3D printers. When we talk about robustness, it is for the repetitiveness, the factor of reliability, and more importantly, these are systems that go unmanned, unmatched in precision, and the factor of durability that they offer with multiple industrial grades of thermoplastics. You would get to see quite a lot of areas of manufacturing applications that have been addressed with Stratasys FDM technology. Even today, the office shared systems are so well offering multiple material outputs. The choice of selection depends subjective to the next level of part utilization from 3D printing. So, well, a brief touch base on the smaller machines that we call them as office shared systems. Yes, these are solutions that has multiple offerings. You have an interface, which is a touch-based interface, which is intuitive. Mobile monitoring for remote monitoring of what's happening on the printers for a long run or on a weekend print. The hardware are highly reliable. You have very well supported softwares called as GrabCAD Print or Insight. Then the material options, multiple materials that are offered, and most importantly, Stratasys solutions from the invention of the FDM machine. Soluble supports are holding in good stead to support any complex geometry realization because it's hands-free support removal. any critical geometries, irrespective of any challenging creative ideas from the designers, you would be able to print them as a single step output. So these are systems that are unparalleled with performance and productivity. Whether it is design ideas as prototypes or for engineering your products to the next level, you have the highest quality, reliability, versatility, ease of use, and more importantly, from ideas to realizing functional parts. If you're going to ideate your designs, if you're going to change based on the outcomes, you'll have a better design that goes into productivity. So for creators, for creative ideas that needs physical evaluations, an ideal cost-effective multi-material technology, the choice of selecting from the multiple industrial grades of thermoplastics that are on offer, you can pick and choose any one material with which you can work, and you can change the material if you're going from concept realization to functional prototyping. All that happens in quick turnaround time. So the market messaging is that we have exceptional value from these 3D printers, and that's exactly where Stratasys scores over. From introducing the FDM technology today, we have 5 different offerings. It's very easy to work with these printers. You have softwares today that could read your native CAD files. No more you need to worry about STL, the triangulations for better surface finish and so on. And these are highly performance-based materials today available, even on office shared systems. And remember, these office shared systems are office friendly. They're pretty quiet. They don't need to be manned. You submit for print and let the printer do its job. That's the factor of reliability from Stratasys. Some quick use case studies on the office shared systems when it comes to consumer goods, consumer appliances, etc. Concept verification, design validation, functional performance, or whether you have to use your work group and to check on each of their design ideas so that the best design can go on to a product. Here is a case study from product design firm for a motocross helmet. It's a venting component that needs to be printed. Given the complexity of its surfaces and with the versatility of working with ABS and ASA, the pain points are addressed so very quickly and efficiently. That's exactly where it gives creative ideas that can be fine-tuned, that can be ideated, and the best designs are taken into the next level of manufacturing. Very similarly, in consumer electronics, we have a smart home switch, and this is an housing which has got small, critical, and highly challenging features. Not easy for any manufacturing methodology to support realizing a physical part. Even the complexity, given the complexity of the design, mold manufacturing is too very cumbersome. It's going to take quite a lot of time and efforts, but with the low-end desktop or office shared systems, you have PC ABS combination, which has been used in realizing this output, wherein these electronic housings that are highly accurate with complex geometries that could address product assembly and functional evaluations. And here comes a more critical moving assembly of a camera lens. This is a cover which has been printed for, again, for consumer products. Critical geometries, fine features, and more importantly, moving parts. All these are printed with the support of soluble support material that really takes out, or it lights out manufacturing, it lights out physical realization of such complex part. So for work groups, you begin with first set of design alpha, beta designs, and then you have fine tuning your designs for the work group to enable better product designs, and not less with the offer-shared systems, you also have the TPU, thermoplastic urethane, so that you can make flexible parts. And that's to give a brief summary in terms about what the FDM offer-shared systems can offer. But let us now focus more on large parts. When it comes to consumer appliances, white goods, air conditioning parts, highly critical, highly component, more importantly, like these are complex geometries. Whether you look at the grill or the air conditioning duct, the fan, or when we're looking at the housing covers, all these could be very well addressed with these Stratasys technologies. When it comes to the washing machine, we have got the drum housing. Well, most of these components we have printed, we have proved to our existing customers who wanted a POC well before they could agree upon in purchasing a machine. So we worked with some of the majors in India who are manufacturing washing machines. We even printed a complete drum housing. And here comes on the right bottom is a very critical base component. Now, this base is going to house quite a lot of components into it, and it has to be strong, durable. More importantly, it has got highly complex features that are very challenging to be machined by traditional manufacturing. Now, I will focus upon this particular base component in the coming slides and talk to you more in detail about what is so very unique, what is so very challenging, what are the advantages, why FDM as a technology for such a large part, highly complex part in a single step printing. This is add valued, highly valuable output in terms about consumer goods manufacturing companies. Because given the complexity, the quick turnaround time, and more importantly, as a single step process, it saves quite a lot of outsourcing, vendor development to achieve that, or struggling with CNC manufacturers to machine that part from a huge block of plastic. Let us look into, in reality, what is that which qualifies a 3D printer for manufacturing. When we talk about manufacturing ready technologies from Stratasys, in this particular slide, a brief overview to summarize in terms about the qualification that Stratasys product lines have achieved. Since because even the smallest or the office-shared systems go into quite a lot of testings, and these have been tested, accepted, and proved by customers, which qualifies Stratasys 3D printers that are manufacturing ready. These are highly durable systems. More importantly, that when you look at 99% of proven repeatable dimensional accuracies, there it speaks about quite a lot of customers, 95% of customers, more than 5+ years since the inception of these small printers. They are continuously using them. 99% of uptime, and more importantly, like 8 unique materials on these systems. And remember, with Stratasys, using the soluble support, there is a zero geometry limitation, ideally. And Stratasys, which manufactures systems from USA, Minnesota in the US, and from Rehovot of Israel, it offers field service centers as well as engineers who have been trained at the headquarters for well over 22+ countries. Now, manufacturing. Yes, Stratasys technologies can support heavy industry and transportation. Now, our focus is going to be more on consumer products, right? So we're going to look at appliances, electronics, pharmaceutical production, furniture and fixtures, medical manufacturing, sporting goods. You can keep naming them. Primary applications, when we talk about it, addresses jigs and fixtures, prototyping as well as replacement parts. What are these? These are end-use parts, parts that go on a system, go on a machine, go on an automotive, etc., are 3D printed. Let us go back to the base component of the washing machine. Now, the overall size is close to 600 millimeters in its length. Now, look at this particular part's geometry. It has got highly complex thin wall sections, undercuts, not easy to be molded. There are overhang features. We call them as undercuts or overhang features that cannot be manufactured by traditional processes unless you have split inserts with complex molding processes, etc. You would not be able to achieve. But all these criticalities in a single step can be achieved, and this has been achieved on the F770 system. And we'll go back to the F770 system once we complete with the F series. Today, F series, there are also carbon reinforced systems. You can work with nylon, carbon fiber reinforced materials. So you can print much stronger, stiffer parts, not just the ABS, the ASA, or the PC ABS combinations or TPUs. You also have carbon reinforced materials with which you can work with. So while we talk about composite ready systems, we have the F370 and the F190, and these are very strong platforms. They are ready for any thermoplastic applications infused with composites, and these materials supplied by Stratasys today can take on any major application requirements for making strong, durable jigs and fixtures, metal forming tooling, work holding devices for CNC machining, and more importantly, assembly fixtures, where it has to bear quite a lot of weight in the automotive applications and so on and so forth, as well as for consumer goods. Now, more importantly, one point that needs to be understood well is it's a complementing technology, as I mentioned before. Additive manufacturing complements with subtractive techniques. So today, while we talk about supplementing technologies, if there is a possibility, we can supplement metal manufacturing of fixtures, end-use application. Traditionally, wherever metal has been used, these have got replaced with high-strength 3D printed composite parts. And these composite materials that we talk about with the CR series, carbon reinforced materials, could address and meet the manufacturing demands and application requirements of various industries. This could enable cost saving, time saving, and that's very crucial. Not just adopting, but how does it serve? Does it address your pain areas? Yes, could save time. You have a simplified process of single step manufacturing, unlike subtractive, wherein for every given operation, you're looking at different manufacturing machines, different technologies to support, and you don't have all of them under a single roof. You would be able to meet your deadlines and stay within your budgets. That's exactly where you will have strong functional prototypes, whether you call them as fixtures, soft jaws, or even component parts, with composite materials that could protect your production schedule. If your toolings are getting delayed, if you've got a downtime in your tool manufacturing or in your production line downtime, all these are well addressed with the CR printers, carbon reinforced printers. And these are systems which are ardent systems. These have been verified time and again, as I say, and the uptime is very high. Dimensional repetitiveness and the factor of durability qualifies these printers to make end-use production parts for consumer applications or for consumer appliance manufacturing. And here is the large printer that we talked about, the F770 for the base. Now here you have a print envelope size of 1000 millimeters, 1 meter by 6.1 by 6.1. We call it as either 610 millimeters on the Y and Z axis, along with the 1000 millimeters on the X, So the longest x-axis with the Stratasys product portfolio, and more importantly, here you can work with both ABS and ASA. And here you also see that we have a 783 millimeters in length of this particular component, where when in comparison to other fused filament fabrication technologies, given the complexity of the geometry, only with soluble support and with the factor of repetitive quality outputs from Stratasys, you get such thin walls and functional parts manufactured in quick turnaround time. But even with other technologies, you have to have multiple splits to print this part. But with Stratasys, the F770 can qualify to print this part as single piece without having to section them. And there you get to see that the cost comparison with major technologies, major competitive technologies, powder bed fusion technologies, right? You also have triple F, you'll have CNC. CNC is not applicable because of given the complexity of the geometry. And the same goes with this particular component. Prototype and injection molded large part. These are some of the challenges that they have had at the very beginning of product development. How could they achieve that? How can they overcome? How can they simplify their designs? How can they see that they have got better product qualifications in terms of sub-assemblies that can happen on? All these are very well addressed only with the large format printing of the FDM F770 printer. Look at some of the areas where we are talking about traditional machining that needs to be sectioned, repositioned, or you need to change them to simplify the geometry. And these are going to call for additional tooling manufacturing costs. So multiple setups, multiple fixtures, and operators' time is called for. And you'll have to have a large CNC to machine them. And if you're going to look at the cost benefits, when you have to CNC machine such complex geometries against 3D printing, ideally Stratasys FDM is the most cheapest. A brief overview in terms about DLP. Here again is a technology we talk about making batch quantity manufacturing, production-based outputs. What is so very unique? We're talking about a resin-based system which can qualify parts with majority of the surfaces that could be addressed as injection molded finish. Such is the quality of output with the DLP process. And more importantly, you'll have material versatility for functional outcomes. Thereby, quite a lot of manufacturers, in order to manufacture small parts, complex geometries, they adopt DLP, Stratasys Origin 1 P3 as a technology for end-use part manufacturing. And when we talk about end-use part manufacturing, I would like to reiterate, with excellent surface finish, you'll have tough, robust prints. Reason, some of the industry majors who are into resin manufacturing, like Enkel Loctite, we have BASF Plastics, we have Avionics, we have Covestro, all these big names worldwide are supporting Stratasys in coming out with newer formulations of resins that qualifies flame, smoke, toxicity certifications. Some of the materials available can exceed to withstand 300 degrees Celsius. Now with such high-end materials, you are able to print robust parts that could be used as production parts on your product lines. That's exactly where we call the P3 as a programmable photopolymerization technology. So you can tightly control your geometry features, dimensional accuracies, and with excellent surface finish and with a higher throughput, industries have the benefit of having end-use part production to achieve hundreds and thousands of parts that can be made with the DLP process. In summary, we talk about it is an inverted process of printing, unlike the FDM or the PolyJet or any other powder bed fusion technology. The DLP is an inverted process. You could see parts are suspended. They enter into a vat which contains material, resin. So you have very high throughput and more importantly, a range of high performance materials. This is the point. This is something that needs to be taken into consideration. These are some of the points that is so very unique only with Stratasys DLP printing. Injection molded part quality. And that's exactly how the DLP process of Stratasys supports industry majors. Quite a lot of industry majors are using DLP for having good batch quantities manufactured. So to summarize on the FDM, let me also talk to you that applications are so very varied. With a polymer-based tool, you are able to form metal. And it could be aluminum, stainless steel, brass, copper, titanium, you can name it. And the choice of selecting to print as per on the right image where you see ABS, polycarbonate or Ultem, these are different materials available on the Stratasys production series machines. So Ultem is a material that could qualify for even having on one small cubic inch of material, you can have compressive loads of 10,000 pounds. Today, Ultem 1010 can bear more than 12,000 pounds of compressive load for any forming applications. And the uniqueness with FDM, to summarize, is the soluble cores. So non-linear geometries without a split line you'll be able to achieve with these soluble support that is available for making soluble cores, etc. So carbon fiber components for lightweighting can also be manufactured. And one important aspect is with Stratasys FDM technology, you have the benefit of also having integrated build. You'll have inserts during printing. Now let me summarize to the final technology, the PolyJet technology. It works with the principle of a moving print head or a printing block, which is called as a head, that constitutes multiple heads, and more importantly, the UV lamps, there is a wiper blade, there is a vacuum suction unit, etc. And this is a snapshot of the J series printers that we're going to look into. What you design, like any inspiration of design that a designer has to refer to or with his creative ideas, here you get to see a smart speaker, which is again a consumer good. You call it as a smart speaker, consumer goods manufactured with a fabric finish. This smart speaker can be achieved in a single print. There are quite a lot of text, colors, all in a single print. What is so very important for any designer, for any industry, all that matters is process matters, right? So what you sketch, your designs have to be brought to life. And that can only happen with Stratasys PolyJet technology. So whether it's a conceptual shape, detailed design, or the final design, it's an end-to-end technology from concept to the final design. Consumer goods. Here you see that AirPods, they are completely printed, including the packaging box. All these are made in quick turnaround time in a single step process. That's exactly where Mr. Jim has to talk about from kinetic vision. It's critical that the end decision maker can hold the final product in hand. So if you're going to look at final end product realization, here you have a technology that can not just let you realize those colors that you design on your computer screens that you see on the top left. You would be able to directly reproduce what you see on your creative computer screens with all those colors, text, prints, with accuracy of colors and labels, without any manual intervention, with very minimal post-processing, you would be able to achieve in a single print. That's where we are going to look at quite a lot of consumer durables, consumer goods, consumer appliances having the benefit of working with PolyJet as a technology. Now, as what you get to see, quite a lot of companies were having to work with packaging solutions with third-party vendors. They didn't have the benefit of having the complete packaging kit available. Here, PolyJet offers you the complete kit. And that's exactly where the visual samples were called as high fidelity models that could combine your 3D product design with all the 2D labeling, the colors, the graphics in a single print. And these could be used as a marketing model for industries. That's exactly where the benefit is. There you see, except for those water drops for the photographer shoot, rest everything in a single shot printing, you'll be able to use a PolyJet printer to get to realize the final product design with colors, text, clear exteriors, clear material, opaque in colors, gradients of colors, no limitation here. There you see the gradients of colors on the right extreme when we talk about colored glass, transparent saturated colors and gradients. Now, how does this give enablement to quite a lot of industry? By now you would have realized, and we'll also get to see very quickly a video which talks about how these digital files are getting transformed as physical outcomes that could be tabled as high fidelity models. Let's hear what Tony has to talk and take us through with getting to realize the benefit of what he's holding on his left hand is a single material output, whereas with the PolyJet J series printer, the color J series printer, he has the final outcome as a single step process.
Vision is an R&D consulting firm that's focused on developing and integrating advanced technology to drive innovation. There are sales and marketing going on every day on shelf at retail through packaging. And that packaging has to impact that specific consumer personally. When you're developing a product around packaging, it's critical that the end decision maker hold the final product in their hands. And that's where adapt to consumers faster and at a higher level than ever. By being able to have 3D printers available for kinetic vision design team, we're able to shorten that design cycle. It's incredible, the impact of the J55 on our process. What we typically do is really amazing images or graphics, and we put that up on the wall, and then we let the consumers or the clients view it. However, with the J55, we can actually get there in just a few days to a place that is on the edge of reality, which is something we've never been able to do. We actually coin the term retail ready prints to where it looks like it should be on shelf, and where in almost the same amount of time we were only going to here. I mean, which one would you want to show, right? So for this particular concept, we were doing a design sprint. We wanted to see what would actually happen if we added the J55 to that process. And so we decided to do a retail drink. And so we developed the brand, we developed graphics, we developed structure, and we did all of that within a 2-week period. Not only are the graphics intricate, colorful, but we're playing with opaque materials, we're playing with transparent materials, which is one of the reasons why we are leveraging the J55 printer, because we can take advantage of all of its unique features to really make those ideas come to life. So we have alternate lids that we've created. You can see that actually intertwines and works. There's actually liquid printed in this, so you're actually seeing the color that's actually inside that the passion tea would actually be colored. So it's printing completely transparent and colored transparent colors at the same time, as well as opaques. So if we were showing this to a client, we can give them every detail of the product itself, which is absolutely incredible. Being able to leverage PolyJet technology, the J55, we're able to jump past some of those firms that are not adopting that technology. We sent this to a customer, and they called us and said, hey, where can we actually buy this product? Because it looks amazing. We said, no, that product doesn't even exist. That's just the product we created. And they were stunned because of the J55 print. They thought it was actually real. We give our customers an advantage. They're able to take their product to market faster, develop better products, be the best on shelf. To be able to hand this to a client and to watch their eyes light up, their mouth open up and say, oh my goodness, how did you do this? How long did this take? That's their responses. It's amazing. And so the impact for them is incredible. And obviously, all of that reflects back on us.
So there you go with Kinetic Vision. We would definitely vouch to see that what we intend to have as a final high fidelity model. Today we have the support of the Stratasys PolyJet J series printers that gives enablement for having full color graphics, text, labels, everything incorporated in a single print. And there you go. You have the design freedom, innovating in a crowded space. And that's exactly where cosmetic design companies and consumer goods manufacturing. So whether you have all those details of graphics etched on the body, the wooden textures on the cap, all of them are compatible to be printed very quickly. So current problems, we talk about 3D printing and traditional manufacturing. So some of the 3D printer parts are weak and quite a lot of challenges when it comes to insider knowledge or for even to train people on 3D printing, and traditional metal geometries are too very limited, and also the time for metal machining is very high. Now, what if there was the right 3D printing solution? You have high strength composite materials, as well as you have functions and user-friendly softwares that could support intuitive functions that can be carried out without any specialized training, as a user-friendly platform, whether you're operating the printable files or operating the 3D printers, it becomes more user-friendly. High strength material means complex parts can be easily manufactured. More importantly, when you're looking at time, all that can be made in a fraction of the time when you're going to make a comparison to machining, which means you're freeing up quite a lot of resources to work on subsequent projects. So it's here now. You can definitely look by staying within budget, meeting your deadlines. This is exactly where the focus has to be. Supplement all your manufacturing tooling with FDM composites when it comes to more durability, or when it comes to design creativity and so on. You have PolyJet, and for batch quantity manufacturing, you have DLP, you have the SAF technology and so on. That's exactly where all these consumer products or the commercial consumer products, whether it's going to be the refrigerators or the washing machines, the vacuum cleaners and so on, all of them have the benefits. Some of the listed names here, Unilever does quite a lot when it comes to consumer goods. Mahle, for their air cleaner, they have been able to do the CFD analysis and not just staying with what the analysis part of it. They wanted to physically try, print and test it out, which they have been able to achieve. And when it comes to HVAC systems, Red Dot uses 3D printing very extensively for consumer appliances parts. And some of these snapshots here talk about OREC manufacturing for vacuum cleaners, and jigs and fixtures. All these support their manufacturing lines. Daikin Applied, again, for consumer appliances. There are certain critical components that can cost them very huge when it comes to injection molding. All these are well addressed. Higher molds company for all these critical components, inter assemblies that needs to be made. It has only been possible with the soluble cores and the soluble support technology that has given enablement for them to achieve such critical geometries and quick turnaround time. So, well, to summarize, let's look at Stratasys technologies. They always elevate the capability. Now, this elevation gives advancement for the right material choices to be made and the selection of the technologies that could support, which means that you have materials, you have repetitive quality from Stratasys, additive manufacturing platforms and technologies. So factory integration is possible. You can have additive manufacturing along with your traditional manufacturing machines to support, and wherever there is elevation in terms about time saving as well as to reduce metal utilization or to lightweight your manufacturing, you can adopt and start working with Stratasys AM technologies. So, well, I have come to the end of my presentation today on the subject of consumer appliances supported by Stratasys additive manufacturing technologies. Well, you can also reach out to us on our social media pages, as well as our contact details of email, which will also be shared as the PDF format once by later today evening, once I complete this presentation, and you can reach out to us more. And now it's time to take some of your questions. So, well, Pranjal, you can take over now and let me know if there are any questions that needs to be answered.
Yes, thank you, Ganesh sir. Thank you for your presentation and good insights of 3D printing for the consumer durables and other industries as well. To start with, we have one question from Mr. Kamesh. So, what type of material are used for soluble support?
Oh, well, it's $1 million question, Kamesh. Since because soluble support materials, they are unlikely to be available. Reason being, these are the R&D, Stratasys R&D, which has created the soluble support as a material, which doesn't have a data sheet to support for you to explore, or neither for us to explore. Reason being, that is the unique material which is soaked in water, which is very, very minimal with soap type of a solution, which can dissolve it. Now, it is very unlikely that the R&D team of Stratasys shares any details in terms about what the support is. It is a support material developed exclusive to FDM as well as with PolyJet as a technology. And these are exclusive materials from Stratasys, which doesn't carry any support details in terms about what the combination of materials that go in for manufacturing.
Well, thank you, Ganesh sir. Uh, Mr. Chandrasekhar Rangaswamy, he has raised his hand. I will just unmute him and we will check if he is available.
Yes, please.
Mr. Chandrasekhar, if you just unmute yourself. Okay, in the meanwhile, sir, we'll take the next question. It is, can we use FDM printed part on vehicle as underhood component for performance trial where vibration may apply from 360 direction? It is by Amitava Datta.
Well, Amitava, when it comes to vibration tests that you can carry out, yes, the versatility of working with FDM as a technology is as such that today we are almost having almost 16 different types of materials to work with. And let me also point out to you that quite a lot of majors in India, automotive majors, are using 3D printed parts as end-use parts for under the hood applications. Now, when it comes to under the hood applications, it's quite a lot of challenges with vibrations, with temperatures, and the factor of durability for such geometries for a product life cycle have been tried and tested. And yes, very widely used FDM materials are available. We have materials such as PEEK, which is called as Antero, polyether ketone ketone, as well as we have Ultem grades of material. We have polycarbonate, we have nylon 12, we have nylon 12 CF, which has 35% carbon fiber filled material. All these constitute for under the hood. The selection depends upon what is the criticality and what is the geometry and what the quantities are required. And they can be a best fit with FDM to address this particular question. And it's very, very widely used. Well, with
Yes.
Mohan Singh Pardeshi, I have another
Yes,
question.
yes,
Suggest
yes,
the
sir. The other
material.
question is suggest the material for FDM to withstand 160 degrees Celsius but having the low cost.
Well, if you're looking at low cost applications for 160 degrees, I do not know what is the duration of time that your testing is going to be. If it is for 160 degrees, we would definitely recommend you to work with polycarbonate as a material, which could be a best fit for you. And that would also be engineering based material and not a very expensive high performance based Ultem or a PEEK type of a cost. So it's comparatively much cheaper and it can definitely withstand 160 degrees C. We did have quite a lot of materials such as polyphenol sulfone when it comes to withstanding 170 degrees Celsius for well over 72 hours. And it is a transmission filter in an automotive part that a 3D printer part was substituted for a machined aluminum, which vis-a-vis would have been manufactured by pressure die casting for production. Now, during testing of a V8 diesel engine, there was a replacement of this aluminum part with a 3D printed FDM part where PPSF was a material used. So ideally for 160 degrees, polycarbonate should be a good substitute for cost-effective 3D printing part for testings. Yes.
Right, sir. So polycarbonate is what you are suggesting, right, sir? Okay.
Yeah.
So we have another question like, can we print a complete airtight part on FDM machine, and what should be the minimum thickness of this?
I don't know who the gentleman has asked this question, but
Same,
very, very.
yeah, it is the same question who had asked about Mr. Amitava, who has asked about the underhood component.
All right. Now,
Yeah.
Mr. Amitava, first of all, for any airtight part on FDM machines, yes, it can be manufactured, but there is no limitation when it comes to the wall thickness if it is a small part. Now, when it comes to large parts, for example, I do not know what would be the size of geometry that you're referring to. However, I could contemplate and look at, if you are looking at a medium sized part of anywhere around 8 to 10 inches or 10 inches plus type of a geometry, you can prefer to have a 2.5 millimeter to 3 millimeter, but the print process, the processing of the file is subjective to certain selections that we do in advanced application training to our users, that we'll have multiple contours. Post printing, we also have certain epoxy coatings with which we seal the component, which means that it becomes more airtight for withholding, whether it is air or any other liquids that you're going to work and refer to for airtight. And subjective to the geometry design, we can also orient a part and pre-process the file accordingly. And yes, quite a lot of areas in the automotive sector where such high-end testings need to be addressed. We train, we print parts and we put them on testing. So there will be a little bit of post processing that will be called off, as I mentioned, coating with certain epoxies for better sealing so that there is no leakage happening and so on and so forth. Yes, it's a possibility.
Okay, sir. Thank. Okay. So yeah, Mr. Mohan Singh, I will share you the contact details of Ganesh sir. We will also contact you. I will definitely share the number after this webinar of Ganesh sir to you. Anything else? Anybody else? If you have any question, if you want to ask anything to Ganesh sir, we can wait and we can. If anybody wants to talk directly with Ganesh sir, I can unmute you. You can just raise your hand or you can type your question, whatever you are comfortable with. Okay, so as I said earlier, I will share the recording with you. Maybe might be tomorrow first half. I will share the complete webinar recording. So if you have any questions, you can contact us. There will be all contact details shared with you all. So do let us know if you have any question. Ganesh sir, I think we don't have any question. But still, once again, thank you everyone. Thank you Ganesh sir for your presentation. Thank you everyone for attending the webinar. So we look forward for more webinar and participation from everybody. So thank you once again. Thank you everyone. Have a nice day.
Thank you, Pranjal, and thank you all joinees. Until the time we meet next time, I wish you all the very best, and do keep in touch with your queries or your questions, and keep us in touch so that we would be able to address any of your requirements, to visit you all and to also provide you more details in terms about every given technology from Stratasys, what could be more ideal that could be adapted in your area of work. So we'll be more than happy to get connected to you. Thank you very much for joining.
Thank you, sir.